All right, welcome guys to the second video here of the 1.1 notes. It's more continuation of the same stuff. Here we got an additional step in here, or some combination of things, where we got to combine some like terms. And then at the very end, we're going to look at some story problems, which would be nice. So we're going to continue on here, the same sort of things here. Now, these are what we call multi-step equations because you got to do more than one step. But the setup and the way you do this is the exact same, which is really nice. So let me start by looking at this first problem here. So we have 5x plus 9 equals 24. So I'm going to do the same thing. Again, once you get used to the setup, you don't have to draw this line to the equal sign, but I just like writing it so I can see which sides I'm going to be working on. And again, our goal is to isolate x. We're trying to get x alone. We're trying to get a solution for just x. Okay. Now, hopefully a lot of you are familiar with the order of operations, and I put them in that Quizlet so you guys can have a quick reminder if you need to look at the order of operations. But we're trying to solve for x. We're going to work backwards from the order of operations, right? So we're going to do everything in reverse. So normally when we tell you to evaluate something, we're going to do the multiplication first and then the addition and subtraction. When you're trying to solve for something, we're trying to go backwards. We're trying to isolate the variable x. Okay? So here, first thing I'm going to do is subtract 9 away. So I'm going to minus 9. And again, just think of isolating the variable. Okay, we're trying to get x alone. Well, with this plus 9 and this minus 9, I can cancel out. And again, whatever I do to one side, I do to the other, minus 9. So now I'm not just left with an x, but like before in the first page, we were just left with an x. Okay, now I've got a 5x equals 24 minus 9, which is 15. So here you're going to see pretty quickly why it's called multi-step equations. Here's the first step, which is what it's called a one-step equation. Now we're doing more than one step, so it's multi-step. So now same thing. What's happening between this 5 and the x? We got multiplication. Well, how do you undo a multiplication? I'm going to divide. These cancel out, and I'm left with x equals 15 divided by 3, which is, or 15 divided by 5, sorry, which is 3. And again, I can always double check my answer by plugging it back in. I'm not going to do this for all of them, but I'll do it for this first one just so you can believe what I'm saying. So I'm taking x is 3, and I'm going to plug it in for x up here. I'm going to substitute in. So I have 5 times 3, right? Again, what's happening between this 5 and the x is multiplication. So 5 times 3 plus 9 should equal 24, right? And that's what we want to verify. Okay. Now, when we're evaluating, now we're going to do order of operations. So now what's 5 times 3 is 15 plus 9 equals 24. So we're just simplifying down, and what's 15 plus 9? That is 24 equals 24. So look at that. We have just verified that this solution is correct, so we are good to move on. Next problem. You go 4y minus 4 equals 16. So again, I'm going to try and isolate my variable. Okay, I'm trying to get that thing alone. So I'm going to try to get rid of this stuff over here. Well, how do I get rid of a minus 4? I'm going to plus 4. And so now I'm left with 4y equals 20. So y here. And again, can't see the operations multiplication. 4 times y equals 20. How do I undo it? Divide. What's 20 divided by 4? Y equals 5. Okay. Same thing on the next problem. Draw a line there. Again, I'm going to try get this guy alone. So I'm going to deal with this thing over here. Well, how do I get rid of a minus 7? I'm going to plus 7. So you'll see how we're getting closer and closer to isolating the variable. So these are going to cancel out. Negative 1 plus 7. I'm starting at a negative, and I'm adding 7 to it. So that's going to lead to a positive 6. right? The positive number is bigger than the negative number, so it's going to be a positive, is equal to z over 3. Okay, well, this is just, here's the sign. So again, we're getting closer and closer to isolating. So now we got to deal with this divided by 3. This fraction bar again means divide, so I got to deal with this. So I'm going to multiply by 3. These cancel out. What am I left with? Well, 3 times 6 is 18 equals z. And again, if you want to verify, go ahead, plug this back in for z up here. And you'll get -1 equals -1. Scroll down here. All right, next problem. Okay, I'm just going to set this up by just drawing a line in between my equal sign. Now, what do you notice about 4w and 2w? Okay, these are what we call like terms. And what a like term is any terms of these individuals are called terms, right? So if the terms have the same variable, so we both have a w, so they have the same variable and the same exponent. Now you can't see any exponents on here, but the imaginary exponent here is a 1 on both of them. Okay, so we have the same variable and we have the same exponent. So these are like terms. So what does that mean? We can combine them together, right? Another way to think about this is I have 4 oranges and I have 2 oranges. If I combine them together, what do I get? I guess 6 oranges. So 6w, right? These are like terms, right? Now, if this was a 4w and a 2x, I couldn't combine this because then you can combine 2 different things, right? I'm trying to combine an orange and an apple, and we know that oranges and apples don't combine. So I combine those together to get 6w, and then on the right-hand side, I haven't done anything yet, so still got 24. Now we got a problem that looks pretty familiar at this point. Divide by 6 on both sides. W equals 4. Okay. Same thing, you got to ask yourself, are these like terms? Well, I have the same variable. I have the same exponent. There's no exponents there. So I can combine these. So I have 8t and I'm taking away 3t. Well, that's like saying 8 oranges take away 3 oranges, and I'm left with 5t equals 35. So now again, this is a problem that we've seen a lot at this point. So divide by 5, t equals 7. Same thing here, okay? Do I have like terms in this problem? Think about that for a second. Well, I've got a 5d and I've got to take away 9d. But do I have the same variable? Well, they're both d, so that's good. And do I have the same exponent? Well, they're both not there, so they're both 1. So yep, so these are like terms, so we can take them away. So if I have 5d's and I take away 9d's, I'm left with the negative number is bigger here. The minus is bigger on the right-hand side, so it's going to be a negative value. This is negative 4d. And then on the other side of the equal sign, I get negative 16. Same thing, divide by negative 4. These negatives will cancel out. These negative 4s will cancel out. So now I'm just left with d on the right-hand side equals, what's 16 divided by 4? It's just 4. Now, one thing that I want to show you is that when you want to verify these, what do you have to do? You're going to have to plug them in. Do you plug them in once? Or do you plug them in however many times you see the variable? So you're going to plug them in. Every place that I see d, I'm going to set it equal to 4. So I'm going to take this d and I'm going to plug it in there. And I'm going to take this d and plug it in right there. Okay. So if I wanted to verify this, I would have to plug d in twice. So let's just go through that real quick. Slide over a little bit. Okay. some room now. So I'm going to say negative 16 equals, now I've got 5 times 4 minus, and then in the blue I've got 9 times 4. And again, we're simplifying down, so we're going to use our order of operations. So I still got negative 16 on one side. 5 times 4, you do multiplication first, is 20 minus 9 times 4 is 36. You can simplify this down. 20 minus 36 is, in fact, negative 16. So now that just verifies that this answer is correct, because this is correct. Those are a little more complicated. They're called multi-step equations. Now, last couple problems here, we got a couple of story problems. We sometimes call the y the output and x the input. Okay, another terms for those are domain and range. Those are other terms for the input and output. So we have the same type of situation here. We got the output of a function is 7 more than 2 times the input. Okay, so what I'm going to do here is I'm going to put a y over for output. Got a y here and x here. Okay. Now another keyword in math is is. Is in math is another word for equal sign. Okay. So we're kind of just breaking this long problem down into an equation that we can solve, that we recognize. So we have the output, which is y, is, which is an equal sign, 7 more. Okay. Well, if you have 7 more of something, what does that tell you? This right here is the same thing, because I'm going to add 7. Right? If I have 2 Oreos and I want 7 more additional Oreos, I have 9 total Oreos, right? I add them together. So this is, so we're going to have a plus 7 somewhere. Okay, so we're going to have plus 7. And then 2 times the input, which is what we call x. So we have 2 times x. Okay, so what we've done is we've written an equation for the function. Okay. So we've written an equation for the function. Now the next question here is then find the input. So you want to find the input. Well, what does input represent? That's your x. When the output, again, output is y, is 15. So again, we're saying that y, again, what is equal in math is just an equal sign. So I'm going to say y is equal to 15. So let me put that in. So I got 15 equals 2 times x, or just 2x, plus 7. Well, this is something that you've seen before. Now we can solve this. So again, isolate the variable, minus 7 on both sides. I'm going to bring this over here, just because I'm running out of room at the bottom. 15 minus 7 is 8, equals 2x. Divide by 2. Divide by 2. These cancel out. 4 equals x. And again, if you want to plug this back into our equation, you will see that that is in fact correct. Okay, last problem for the first set of notes here. So again, the output of a function, y, right? So output of y is another keyword in math. So there's your equal sign. 4 less than. Okay, so think about what that means. And then think about what this means, 4 times the input. And again, input here is x. So take a second, think about that. And look at what I wrote. I got 4x minus 4 equals y. And think about it. Is that correct? So I'm going to work a little backwards. I'm going to look at 4 times the input. 4 times the input, I have 4 times x. So that's this guy right here. Okay, so that's good. And I need to go 4 less than that. So that's less than is a subtraction. It's a minus sign. So that's where this comes in. So this right here is right here. And then there's my equal sign. And then I have a y at the end. So this right here is your equation for the function. Now the question is, same thing. Find the input. I want to find x when the output is 3. Okay. Find the input when the output is 3. Okay. So again, output represents my y. So I'm going to put a 3 in here. And then 4x minus 4. Now I'm solving this, so I can add 4 on both sides. Get 4x equals 3 plus 4 is 7. Divide by 4 on both sides. These cancel out, and I'm left with x equals 7 over 4. And again, if I take this and plug it back in here, I get the exact same answer. So that's the end of the 1.1 notes, guys. If you have any questions, again, talk to your teachers who are more than welcome to help. If you can't read anything, please feel free to send me an email, let me know. But thanks for watching.